All right, so in this unit, like I said, we talked about length, then area, next is volume, then mass, and finally density. So we'll move on to volume. So if we talk about the volume of an object, what does that mean? What is volume? Herschel? Not quite. That's you can, Emma?
How much space it takes up?
Yeah, it's the amount of space that the object takes up. How much space does it occupy? That's what volume is. So we can find the volume of objects in a few different ways. You're going to have to know about some of these ways and be able to do them. First is to find the volume of a regular shaped solid. So this is a solid that has some regular, predictable shape. We have a formula that we use to calculate the volume. For example, what shape is this?
Cylinder?
Yeah, this is a cylinder. It's a regular shape. We have a formula we can use to find the volume of this by calculating. What shape is this? Ashley? A cube. If this were not exactly a cube but rectangular, what would you call it?
A rectangular prism.
Rectangular prism. I always call it rectangular solid, but I know you guys now call it prism. But okay, yeah. So this block of solid gold, that has a formula that we can use to calculate its volume. We also have formulas for like a pyramid shape or a sphere. We're not really going to use those formulas, but they do exist. So if it's a regular shape, our best method, our most accurate method, is to measure various dimensions and then calculate it. All right, so we're going to just use two formulas really in class. We're going to use the formula for a rectangular prism and a cylinder. And they're both pretty easy to remember. So the volume of a rectangular prism or a box or rectangular solid is 1 for a cylinder is 5. If you notice anything about these two formulas in comparison to the area formulas we were just using? Courtney? Yes, they're basically the area of a shape, but then it's multiplied by what, Nicole? The height. You can imagine, we could find, if we pi r squared, we're going to find the area of this part of the cylinder. Then by multiplying by height, we're taking into account the height, and that gives us a three-dimensional volume of the cylinder. So we are going to always follow the same steps when we're calculating volume. Same steps we use for air. So what are those steps? First, we do what? Write the formula. Second, Bianca? Plug in the numbers and substitute. Third, Joey? Solve and include units. Yes. So for this shape, obviously, I made very simple numbers that so we start with the formula. Volume equals length times width times height. Substitute our numbers. 3 centimeters times 1 centimeter times 2 centimeters. Solve. Now units. These units make sense? Oh, we have centimeters times centimeters times centimeters. Good question. What would you do in that case? Nicole? You have to convert them all into like units. So, you know, if you have millimeters for one and centimeters for another, you'd either convert them all to millimeters or all to centimeters. And if you were using all millimeters, what would your final units of volume be? Emma? Millimeters cubed. All right, so here, same situation. Formula, pi r squared times height. Substitute our numbers in. What's the radius of this cylinder? Nicholas? Yes, 3. I'm giving you the diameter, so the radius is 3. The height is 8. So 3.14 times the radius squared times height. Now, do our units still make sense? Because pi doesn't have any units. So is this still okay, Bianca?
Yes.
How come?
Because pi is just pi, you just multiply it by.
Yeah.
I don't know how to explain it.
Yeah, you're right. And so centimeters, for squaring it, what do we get?
9.
Well, for just the units. So centimeters, we square the number, but we also square the units. So centimeters times centimeters is?
Centimeters squared.
Times this centimeters.
Centimeters cubed.
So our units are still okay. Yes. And the final answer we get is 226.08 centimeters cubed. So that's one way to find the volume of a solid, a regular shaped solid. Bianca, did you have a question?
It says 9 centimeters squared, but wouldn't it not be squared because you just multiplied it to square it? Or would it still be?
It's still, so this 2, oh, I see what you're saying. This 2 is only going with the units.
Oh, okay.
It's centimeters squared. So it's 9. So this is 3 centimeters, parentheses, squared. This is 9 centimeters squared.
Okay.
All right. So those are regular shaped solids. Well, what if we have a liquid? Now, we don't measure the length of a liquid or the area of a liquid, but we can measure the volume of a liquid. And how do you do this? We do it using a tool called, what is this? Graduated cylinder. Okay, this is a graduated cylinder. Now, I want to be clear, we do not use, what is this? Joey? A beaker. A beaker does have lines on it that give you a rough idea of how the volume of liquid in there, but this is not at all accurate. Okay? This is used for sort of estimating a volume. This is used for measuring volume, graduated cylinder. We have all kinds of sizes of graduated cylinders that we may use. You know, here's a very small one. Here's a little bit larger one. We have this size. So, which one should you use? How do you choose the best graduated cylinder? Nicole? Yes. You always want to choose. Ashley?
One that has like more like millimeters and
Yeah. You always want to choose the smallest. The smallest one that will accommodate the amount that you have. Because the smaller the graduated cylinder is, the more accurate. Because in this graduated cylinder, each line is 0.2 milliliters. However, on this graduated cylinder, each line is 2 milliliters. On this one, each line is 1 milliliter. So I can be more accurate using this graduated cylinder. I can be accurate down to 0.2 of a milliliter. This one I can only be accurate up to 2 milliliters. So the smaller one gives you better precision in your measurement. All right, so we want to find the volume of a liquid. Basically, just pour the liquid we are interested in measuring into the graduated cylinder. Okay. And what you'll see is that it's going to form a curved surface. When you have water in a narrow tube, it forms a curved surface. That curved surface is called a meniscus. And so how should I read this meniscus? Nicholas? Yeah, you always read the bottom of the curve of the meniscus. So what's the volume of water I have shown in this picture? Nicole? 10.1. Emma?
11.5.
Okay. Anyone else? Jonathan?
11.6 or 11.7.
Okay. We'll say 11.5. So what we have to be careful of here, so we see our lines on our graduated cylinder. So here, let's say, is 5. Here's 10. So what is, the question you have to say is, okay, what is each line worth? So if this is 5, is this 6?
No.
No, that wouldn't make sense. We have 5, 6, 7, 8, 9, 10, 11. No, that doesn't make sense. Okay? That's 5. What is this one? 5.5, 6. 6.5, 7, 7.5, 8, 8.5, 9, 9.5, and we're at 10. So on this graduated cylinder, each line is worth 0.5. Depending on which one you're using, that may change. So you have to look at it carefully to figure out what exactly each line indicates. So here we have 10. That'd be 10.5, 11. And you can see the line here, and the meniscus is right at the bottom of that line. So I would say 11.5 is going to be our best indication. Now if we have a gas, gases expand or contract depending on pressure and how much space they have available to them. So we don't really measure the volume of a gas. Okay. All right. So when we do measure volume, if we're calculating the volume using a ruler and using a formula, we generally use cubic centimeters, centimeters cubed. However, if we're using a graduated cylinder, we usually measure it in milliliters. Okay? And 1 milliliter and 1 cubic centimeter are equivalent to each other. They're the same volume. If you ever heard of cc's, like maybe on like a medical show or something, cc stands for cubic centimeter. All right, now sometimes, however, we have an object that we want to measure the volume of, but it's an irregular shape. For example, this shape here may look like a cylinder, but it's not. It has this hook thing in it. It's got a big hole in the bottom and then 2 other holes. So this is a more complicated. We call this an irregularly shaped object. Okay, so I can't use a formula to find the volume of this. So I need an alternate method. The alternate method is something called water displacement. If you have, say you're going to take a bath. You're sore from running cross country all day. You're going to take a bath to relax your muscles. You fill up your tub really high, hot water. Then you get in. What happens to the water level? Chloe? It rises. How much does it rise? Courtney? Yeah. The volume of increase in the water is the same as the volume of your body. So you can actually measure the volume of an irregular object by placing it in some liquid and seeing how much that liquid increases. And that's the volume of the object. And we call that water displacement. So for an irregular object, we put some water in a graduated cylinder, like this. We then record the volume, place our object in. The volume will change, obviously, and the difference is the volume of the object. We just subtract, and that's the volume of the object. So for example, I put 55 milliliters of water in a graduated cylinder. I add a small rock. The new volume is 63 milliliters. So the volume of that rock is? Grant?
8 milliliters.
8 milliliters, yeah. So water displacement is another way to do it. it's not quite as accurate. There's more space for error than measuring an object. So if you can, you always want to measure it and calculate the value. If you can't do that, then water displacement will work. Well, sometimes, though, we have another situation. Now I have this object, but it doesn't fit in here. Okay? So one other way that I can do this is use a tool called a spill cup. So I'll show you that over here. So what we have is, anyone know what principle this is called? Named after a famous Greek scientist. He said Eureka. Got in the bathtub. Joey? No? Archimedes. So anyway, so I have this aluminum cup. It's got a little spout on it. And what you do is you fill it up until it overflows out of that wall. All right, so then, obviously it's full right up to that level. Then, if I place my object in there and capture all of the water that comes out, being careful not to splash. Oops, lost a little bit. But anyway, if I capture all that water, now the volume of water in here is equal to the volume of that shape I put in there. Okay, so it's about 62 milliliters. So that's another way we can do that. All right, any questions about volume?
I just have a question about that little circular thing around it.
Yep.
What is that?
The circular
Thing around the tube.
Oh, that's just so that if it's on its side, it doesn't roll. Veronica?
Do you put the cylinder on